Today we're going to talk about transformations of functions. First thing we'd like to discuss is families of functions. And we're familiar with lots of different families of functions. So that handwritten sheet that we worked on Friday after the quiz deals with lots of families of functions. So we have linear families. If we were together today, I would ask you to give me examples of ones. This is the parent linear. Let me just write it above it, parent linear function, because it's the simplest equation for a line that we could have. Next we could have the parent quadratic. So you can see this family idea. We even have parents. What's the simplest type of quadratic we could think of? We could have a parent cubic. So anything whose highest power is a x to the third would be a cubic. But this is the parent cubic because it's the simplest, coefficients of 1. We might have, these are all just parent functions. I'm going to quit writing parent though. Absolute value. The parent function would be absolute value of x. Square root. Cube root, different roots. Like I'm forgetting a few. When we get into trig, we could have the trig functions, so like sine x, cosine x. We get into exponentials. We could have exponential functions like 2 to the x. And one just was in my head and then it just popped out. Oh, rational functions, where you've got a ratio or a fraction with x in the denominator. So these are just some families of functions, and what's super nice about them is they all behave the same way when we think about transforming them, transformations or changes that we could do to them. So first off, we'll talk about translations. These are slides or shifts. So if you take your function and you subtract k from it, that is a shift k units down. If you take your function and you add k to it, that shifts the whole function k units up. So, for example, if we took then that takes the parent quadratic, which sits at the origin, and it shifts the whole thing up 8. So it's now up here. It's got the exact same shape. It's just all been moved up 8. Every point gets moved up 8. All right, so we've got the downshift and the upshift. If we have x plus h, this is actually h units left. And let's get the other one. X minus h is h units right. Excuse me. So the formula is x minus the shift. And if you think about it that way, you've got x and then there's minus, and this is a positive h. So that's a positive shift, right? And this one also, if you rewrote that addition is minus a negative, you got your h and your minus, and this is the shift. So that makes sense that way, that it would be H units left. And another thing to think about, I'm going to get rid of the green that I've done. How do you tell the difference between an up and down shift and a left and a right shift? The vertical shifts occur to the entire function. So you're taking your whole function and you're adding or subtracting something from it. But the horizontal shifts, the thing that you're adding or subtracting is inside the function with the x. So it's immediately affecting the x, and the x-axis is the left and right axis. So that's causing a horizontal shift because it's affecting the x. Okay. So, for an example, what if you had x plus 4 to the second power? Then that is taking the parent function and it's transforming it or changing it. And the thing that was different is this plus 4. So it's in there with the x, so it's horizontal. It's affecting it horizontally. And it is sort of the opposite of what it looks like. So it's actually left 4. So it kind of looks like it's plus, it is plus 4, but remember it's x minus negative 4. So it's causing a left 4 shift. So some people just like to look at it and say, well, it's the opposite of what it looks like. And horizontal kind of works that way a lot. It's got a lot of things with opposites. Okay, so now let's think about reflections. Reflections or flips. If we have this function here, the square root function, and we put a negative in front of it. So if you have a negative of your entire function, that is a vertical flip, or it's a vertical, I'm going to right flip, it's vertical flip, so we're going to flip it down here. So that's a reflection over the x-axis. So if it happens in front of the entire function, it's a vertical flip right over the x-axis. But let's put this square root function back. If you had that same function and you had the negative under the root like that, where it's affecting the x, if it affects the x, x is our horizontal axis, then it's causing a horizontal flip. So we're going to flip over here. So it's a reflection on the y-axis. And this is the symbol for that reflection over the x-axis. And this is the symbol for the reflection over the y-axis. All right. 2 more rules to think about. These might be review, they might be new. I guess the same could be said for this whole lesson, because I'm not there with you to be able to ask you. So now we're going to talk about dilations, and we can either discuss stretches or compressions. And you could think about your pupils. If you go out into the sunlight, your pupils will compress and get smaller. But if you're in a dark room, your pupils are going to get larger, stretch open wider to let in more light. So that's the dilating of the pupils. It's kind of directly related to function transformations with dilations. So first off, let's think vertically. If you have a times f of x, and a is greater than 1, then that is a vertical stretch by a factor of a. But if you have a times f of x, and a is some fraction between 0 and 1, then this is a vertical compression. Some books call them shrinks. By a factor of 1. Of a, I'm sorry. So if we were to look at the square root, the x squared, and we want to make a transformation, and we want to do 3x squared. So that's 3 times our function. So that's our a. Since that's greater than 1, this is a vertical stretch, a factor of 3. So what it does is it stretches up faster. Okay. Now horizontal dilations. Also have stretches. So a horizontal stretch looks like f of bx. So horizontal, it's in there affecting the x. If b is between 0 and 1. So if b is a fraction, then it's actually a horizontal stretch. So it's completely the opposite of the vertical. By a factor of 1 over b. So it's the reciprocal. And then you would have a horizontal compression for f of bx if b is greater than 1. So it's completely the opposite of vertical. And it would be by a factor of 1 over b. So for example, if we took the absolute value, parent function, and instead we looked at absolute value of 1/2 x, well, that 1/2 is inside with the x, so it's horizontal. That is between 0 and 1, so for horizontal, that's a stretch. And the factor is 1 over 1/2, which is the same thing as 2. So it's really just like a reciprocal every time. And a horizontal compression I'm actually not going to show that. Alrighty. So let's see what some of these examples might look like. Let's see. Our directions are, I'm just going to do one of each. Given each function, identify the parent, and the transformations from the parent. So for our first one, if we have f of x equals, let's see, 5x to the third plus 2. First one, she's going to identify the parent. Well, this is an x cubed, so your parent is f of x equals x cubed. And then you've got to say, what did the 5 and the 2 do to it? Well, the 5 is multiplied by out front of the x cubed, not inside with it. So it's a vertical, because it's times the whole function, times the x cubed. And because 5 is greater than 1, it's a stretch by a factor of 5. And then the plus 2, that's happening to this x cubed. It's not inside with x. It's happening to the whole thing. So it's a vertical shift up 2. We'll do one more. Okay, let's say we have that. Well, if you kind of strip away all the extra numbers, then the parent is what you would be left with, is 1 over x. So it's the parent rational. So I see that 2 in front of the parenthesis. That doesn't mean it's multiplied by 2. It's actually multiplied by 1/2. So we have that 1/2 is times our whole function, so that is vertical. That's between 0 and 1, so it's a compression by a factor of 1/2. And then inside the parentheses here, we have the -6, so since it's affecting the x, it's horizontal. And it would be the opposite of what it looks like, so it would actually be right 6. And you can double check these. You can plug the parent into y1 and plug your transformed equation into y2 and see if what we think happened actually happened. All right, and then the back sheet, worksheet 27 is kind of going the opposite way. They give you a graph. And they want you to identify the parent. And then write an equation for the transformation. And then write the equation for the transformation. So 2 things we have to do. First thing, identify the parent. So it's f of x equals square root of x. And then they're going to have a set of information for us. So we want to reflect on the y-axis. And we want to shift it down 6. Okay, so we want to write the equation down of what happens to this once we do these things to it. Okay, so reflection on the y-axis means it's multiplying by a negative, but since we're reflecting like horizontally across the y-axis, then that would go inside with the x. The negative would be inside with the x. And a vertical shift up and down 6 would just be on the outside of the function. Whoops, down. -6. All right, good luck. We can talk about it Wednesday.